Hi you guys, today we're going to be learning about standard deviation. There are actually two, no matter what you're finding the standard deviation, however it's going to be a population equation versus a sample equation. So we're going to go over one of each today. So for your notes, this is going to be standard deviation and this is going to be the population way. So either way, we do have population. This one we're going to be calculating kind of like the whole world as you can think of it. So no matter what, the standard deviation is a measure of how the values in a data set vary or deviate from the mean. That's what standard deviation actually means. Our formula for calculating standard deviation, the population one, this little symbol, you guys can actually, I gave you the little chart right here of what each symbol actually means. So this is sigma. They're all Greek letters. So sigma, that represents standard deviation symbol. And then we have this summation sign right here, which that actually represents sum. It's called sigma. It's the sum of all the numbers. And then x is just going to be each of our data values. And then we have x to the bar on top means the mean. And then we have n is the number of data values in the data set. So make sure you guys write down this formula, and that little sigma sign, this one is just like this. That's what it actually looks like bigger. So go ahead and write down each of those, and then we will actually go through an example together on the next slide. Sorry, we're going to go over our steps first. So you're going to calculate the mean, that's step one. Then we're going to find the difference between the data value and the mean. Then we're going to square each difference. And then we're going to find the average, the mean of the squares. And then we're going to take the square root of the mean of the squares to find the standard deviation. And that's probably all a bunch of mush right now, so just go ahead and write down those steps, and then now we will go into an example. So these numbers right here are actually the numbers that we're going to use. So we're going to go ahead and plug in. Remember, X stands for the actual data values. So I'm going to start off with 12.6, then I have 15.1, 11.2, 17.9, and 18.2. I might not have to use all the spaces, you guys. I just gave you extra ones just in case. But we want to double check we have the same amount as numbers that we do. 4, 5, 1, 2, 3, 4, 5. Perfect. Okay. So now we need to actually find the mean for these values here. So when we find the mean, we're going to add up all those data values and divide by 5. So when we add them all up, we actually get 75. I'm just going to do the side work over here. And we had 5 numbers. So now we're going to go ahead and divide by 5, and we get 15. So that's going to be our mean, and you're just going to rewrite it for each of these values here. Okay, so then now once we have our mean, this just means that we have our data value minus the mean. So we're literally just going to do 12.6 minus 15, 15.1 minus 15, minus, minus, and minus. So when we actually calculate those, we get the values of, for the first one, you want to make sure you guys are putting the negatives as well. So you're going to have negative 2.4 here. Then the next one, 15.1 minus 15, you get 0.1. 11.2 minus 15, you get a negative 3.8. 17.9 minus 15, you get 2.9. 18.2 minus 15, we get 3.2. Okay, so that's what that little symbol means. You're going to take your data value minus your mean. Now, this is literally the same symbol as our last step, but now we're just going to square them. So everything is basically going to come positive, and we're squaring it. So now I have a negative 2. I'm going to do my work over here so you guys can see it. Negative 2.4 squared. So when I put that in the calculator, I get 5.76. I'm just going to write these all out, you guys. So 1.1 squared, negative 3.8 squared, 2.9 squared, and 3.2 squared. Okay, so now I'm actually going to square those and enter them in my column. So for this value I get 0.01. You could also put the 0 before it if you like. I get 14.44 here. Next one is 8.41, and then 10.24. Okay, so that is now squaring all of them. Now, the new symbol that occurs is the sum of all of the squared terms, so that's going to be my first step, and then we're going to divide by the number of them. So basically we're just taking the mean, but instead of these values, we're now taking the mean of those values. So I'm going to add 5.76 plus 0.01 plus 14.44 plus 8.41 plus 10.24. When I add those all up, I end up getting 38.86. Again, we're finding the mean. N stands for the number of data values, and there were 5, just like in our previous one. So now when I actually divide that by 5, I actually get our final answer, which is 7.772. I'm just going to go that far. Then, our last standard deviation is to take the square root of that entire thing. So when we go ahead and take the square root of 7.772, we get an approximation here because this decimal ended up going longer, but now we have a decimal of 2.79. Alright, you guys, so that's your population standard deviation. Now we're going to go on to a sample standard deviation. So a sample standard deviation is going to be all the same steps as our population standard deviation, except for when we divide by n back on this step right here, we are now going to make it an n minus 1. So I will show you guys that actual sample standard deviation. So you guys, the difference between like population and sample, population is like saying we're taking a survey and we're going to get every single person in this entire world actually to get the survey. So sample standard deviation is saying, okay, let's be more realistic, and can we actually get the whole world to actually take the survey, or can we get like a majority of like say a couple states or something like that to actually take a survey? So it's taking a sample of the actual data that we're trying to collect. Now, so we're going to do the same process here. All of it is the same process, literally, you guys, until you get to here, and this is the only thing that's different. So this is our only step. So again, we're going to go ahead and list all the numbers in our x. So I just took this list right here and I wrote them all in for our x values, our data values. Now I'm going to take the mean of this. So I'm going to add all of those up and then divide by 5. So let me go ahead and add all those up. And when I add them all up, I get 72.5, and then when I divide by 5, I end up getting 14.5. So again, I'm going to go ahead and write all those down for this. And then my next step is to subtract those values now. So now I'm going to go through 13.4 minus 14.5, negative 1.1, 11.7 minus 14.5, negative 2.8. You guys, it's okay to have positives and negatives here. That's what you should be having. So 18.3 minus 14.5 is 3.8. 14.8 minus 14.5 is a 0.3. And then 14.3 minus 14.5 is a negative 0.2. Okay, so now our next step is to square all those. So when we actually do negative 1.1 squared, I get 1.21. Negative 2.8 squared is a 7.84, so this is where all your values should turn positive and be squared. This is a 3.8 squared, 14.44. 0.3 squared is a 0.09. Negative 0.2 squared is 0.04. Okay, so now, just like how we found the mean over here, I'm going to do that. I'm going to add up all these. So when I add up all those values, I get 23.62. And this was the same work I was doing in here, you guys, 23.62 from our last example. And then now, this is the only step that's different, you guys. So instead of dividing by 5, where we originally did, we just divide by 5 minus 1. So now we're dividing by 4 instead of actually dividing by 5 there. That's the only difference. And so when I divide by 4, I get 5.9 and then 0.5. So I'm going to go ahead and keep that. And then we still square root it, just like we normally would. So when I take the square root of 5.905, I end up getting 2.43. And that's my sample standard deviation. All right, you guys, so I will see you in class. We will go over a couple of examples and questions when I see you. Thanks.